Cape Home Centers and Save Our Sound, as well as the Hyannis Chamber of Commerce for giving us the opportunity to present our technology and how the technology can apply to the state of Massachusetts. In December of 2007, Blue H Technologies BV launched the world's first floating but fully stabilized wind energy platform in the world. The unit is now fully installed, 371-foot waters, 11.5 nautical miles off the coast of southern Italy in the region of Puglia. This is the world's first floating wind energy platform. We believe that this technology has strong applications in terms of addressing and tapping the potential technology off the coast of the United States. Important in terms of the United States is that over 90% of the resource offshore is in deep waters. So if the United States is going to be able to address and tap its potential resource offshore, we're going to have to develop technologies such as Blue H in deep water. In terms of accessing and tapping into the demand centers, it's important to have and develop deep water wind energy technologies. 900,000 megawatts, according to the National Renewable Energy Laboratory, of wind energy potential is located off the coast. That's the equivalent to the full U.S. grid. We are targeting deep water technology. We plan and hope to become one of the world's largest developers of deep water wind farms in the world. The company has a strong international team that's well experienced in developing offshore platforms, also in wind turbine technology. The beauty of our technology is we don't involve in any construction at sea. We don't have to prepare the seabed. We don't need any industrial equipment in terms of building the units out at sea. We just tow the fully constructed unit from the shipyard out to the location. The offshore wind energy industry never really started off with a clean sheet of paper. Basically, the problem has been developers of shallow water technology have taken existing onshore turbines and put them in shallow waters, but haven't designed units that can withstand the harsh marine environment. So Blue H took into all the problems that were encountered in the shallow water industry: user group conflicts, environmental problems, cost considerations, safety units, and this is how Blue H Technologies born this concept of deep water development, realizing that there's some inherent problems with the way business is being done with the shallow water industry at this point in time. Further you go offshore, wind speeds are relatively stronger at lower altitudes. So we can build lower towers because we can access stronger, higher quality, less turbulent winds. There's a new advance in cabling technology called high voltage direct current technology. With this cable technology, we're enabled to have oil-free cables, cables that have neutral electromagnetic fields, and cables will also allow us to have a compact converter transformer station. Now this development in technology is analogous to the technology that was developed by Ethernet cables for the internet. Basically, it's creating a more reliable power supply, more efficient, less losses, and has brought the cost down significantly to make deep water development more viable. With our technology, we can deploy in an area between 30 and 300 meters. This gives us the opportunity and the luxury to take into account shipping lanes, ferry lanes, airline traffic routes, marine mammal migratory paths, fishery locations, avian locations, put all of the variables on the table and find the area that is least contentious in terms of user group interference, in terms of sailing, shallow water fisheries, sport divers, far away from shipping ferry lanes, and find the area as well that's more optimal in terms of average wind speeds, and also that's able to tie into a grid in an area that needs additional electricity production. In March of 2008 this year, we filed a nomination for lease with the Minerals Management Service. We're hoping for a review within the next couple of months to have a final decision on this application nomination for lease. This is an important development for the United States because this in effect launches the deep water wind energy industry by having U.S. facilities involved in the construction and the commissioning of an actual deep water wind energy unit. It's important to start that learning curve early on. We believe that this is not only important for Blue H USA, but also for deep water wind energy development in general. With our deep water location, we're able to get a capacity factor that's over 10% higher in relationship to shallow water locations in nearby This gives us a fantastic opportunity to be much more viable than shallow water locations where you have only a narrow band of deployment opportunity. We don't have any assembly at sea. That's a tremendous cost advantage. With shallow water technologies, you have to have crane ships and jack-up barges, which A, are very difficult to find. B, if you can get them, they're at a cost premium. With this technology, we don't assemble anything at sea. Our technology is fully assembled onshore at a shipyard with a bulkhead and a submersible barge and towed out to the location. We don't need to prepare the seabed. When you construct a shallow water turbine, monopile turbine, you have to level the seafloor. With our technology, we can lower our counterweight on an uneven seafloor and adjust the chains hydraulically so that unit is straight up and down. That, in terms of environmentally being invasive to prepare the seafloor, is a process that requires time and equipment and is very disruptive to the